But what we did, oh, thank you, Sean. I meant to do that. Um, so this is really a take on what Orca's customers are doing with AI and the applications they're building and deploying. So a couple of things here. This is not about how they're using ChatGPT or similar SaaS services. This is about what they're shipping and building themselves across the entire fleet, which is an important distinction. I often say I am an AI skeptic, in particular a generative AI and LLM skeptic. I don't use ChatGPT for much. I have had all sorts of problems with AI features in products in the market. I own a vendor relationship at Orca, and in their platform, they were very excited, breathless that they just added generative AI, and I could do all of this stuff with it. And so on a call with my customer success person, they demonstrated it for me. And not making this up at all, the third time they demonstrated it for me, it generated results that talked about things that Orca was doing that did not exist. It talked about new features in our product that did not exist, partnerships that did not exist. It was, to use the technical term, bullshitting. And at which point I was like, I don't know how I can ever use this, right? None of this talk, I don't care. It doesn't matter how I feel about AI. What it matters is that this is happening with or without us. And as security people, we have to be thinking about what do we do. And so let's dive into this. And this is the first one. So over half, and these numbers are a couple of months old. If I ran these today, it'd probably be 59, 60%. Over half of the organizations we look at have already adopted AI models in some custom applications in what they have deployed in the cloud. So for me, this is the clarion call right here, right? Just as 8, 10 years ago, we were talking about all of the businesses rushing to the cloud with or without security teams. We were talking about shadow cloud. We were talking about shadow IT before that. This is something that our business units are rushing into and doing, whether we are ready for it or not. And so, this is really, we've got to think about, where are the problems? Where are our guardrails? Where is our policy? What does that look like? And so, sort of going from there, this is actually probably the least surprising number to me in here. The only thing surprising about it is that the risk is lower than I think it probably should be. So we broadly see AI packages, AI components deployed with vulnerabilities. Now, it turns out today those vulnerabilities are generally not publicly exploitable, or they don't have public exploit code, significantly less so than the average asset, the average vulnerability we see. They're low to medium risk. Don't take that as a good sign, though. I think this is the beginning of a curve, right? Vulnerability researchers and people who write exploit code go and look where things are being used. They look at the most popular components or the components that have the most impact. Given what we saw on the first slide, this is an indicator that those same researchers will be going and looking at AI components as we move forward. So I fully expect there are high and critical severity vulnerabilities already out there that just haven't been discovered. But we know that today they exist and they'll be growing. Quick look, these are the ones that have vulnerabilities. Like I said, they're not that critical today. We expect them to become more critical. This is where it gets really interesting. So this is a problem that's already been solved, and yet 45% of the SageMaker instances we see are using buckets with a non-randomized default bucket name. Now, let me tell you why that's important. You can read all the text on here. These, by the way, I did not create these slides. When I create slides, it's normally like 5 words and a picture. These are from marketing. This is sort of part of the report. There's a lot of text here. Don't try to read it all. So if you look at how S3 buckets get compromised, it is not enough to just create an S3 bucket that's publicly readable. S3 buckets aren't discoverable on their own. So if I have a publicly readable S3 bucket in my account, somebody has to discover the name of that bucket before they can read what's in it. And so best practice is to have bucket names that don't follow some easily discoverable pattern. Now, Amazon SageMaker, which is a service, it's SageMaker productized by Amazon, automatically creates an S3 bucket to store your files, and it was automatically creating it in the form SageMaker-region-account ID. So Aqua Security discovered this, and it meant that basically I could start guessing. If I could figure out your account name, I could start going and finding these buckets. So it put them at risk. Now, a couple of things here. First of all, this is something I'll come back to, but a lot of times when we look at new services, when we look at DevOps-driven services or developer-driven services, they are not secure by default. And this is a great example of that. So there's a good reason CIS is talking about secure by design, secure by default. This is something that prior to Aqua reporting this to AWS and AWS fixing it, it was not secure by default. I could make it secure. I could change the name of that bucket, thus to not follow some default naming convention, make it harder to discover, but I had to do that. If I just click next, 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 okay, what I got was less secure than it ought to be. And I think this is a problem that broadly impacts sort of where AI components and AI things are today. Is a lot of times they're built for simplicity. They're built to be quick to deploy and start playing with and testing things and building things. It means that they don't necessarily meet what we would think of as best practice. And so speaking of that, actually, we're skipping. Sorry. I get my slides out of order. But this is another significant set of problems around AI. If we look at sort of reported attacks on AI today, there's the one that I've seen most common is people finding access keys for an AI service and reselling access to your AI services to other organizations. So effectively, just like crypto mining on, if I find an AWS secret that I can use to get into your AWS account, this is a way of just directly monetizing that thing that's found. And what we found was that a ton of organizations have an access key to one of these services exposed somewhere and available somewhere where it's not properly managed as a secret. And we fully expect attackers to take advantage of that, either to monetize that, or worse, to follow some of the other approaches to poisoning data, reading your data, taking advantage of it, doing interesting things with it. And this one's not surprising as well, but fun story. In 2023, we did this honeypotting report. I've talked about it in the past. But if you expose a secret in a public GitHub repo, it'll be found and used in about 2 minutes, and then it'll be used continuously after that. So what you would naturally do if you've never really spent a lot of time thinking about how Git works is you would delete that secret, check in that update to that branch where you exposed that secret. Now you can't see it in that branch anymore. It's not enough because Git keeps a commit history. It shows you every change made to the branch, and attackers will find keys stored in your commit history just as quickly as they'll find them in the branch itself. And so what you have to do is know how to do, as I recall, it's a rebase. I have done this myself in the past and had to go figure out how to remove it from my commit history. It's painful, but you have to have a plan. Either know how to remove it from the commit history, know how to rotate the key, probably do both, because 2 minutes it's going to be found. You're probably not going to find it in 2 minutes. But what we saw is that there are a ton of exposed access keys in the commit history as well. Now this is where I get back to secure by design, secure by default as well. This is an interesting one. So if you think about it, something like SageMaker, which is a way of building and testing and working through things. I'm going to be able to escape SageMaker to the underlying EC2 instance, the underlying VM, and from there elsewhere in one of two ways. If it's running with privileges on the VM itself, so it's running as root, and if that VM is running with privileges in the cloud. So when I spin up an EC2 instance, it has an identity. That identity has roles associated with it that give it the ability to do things. Hopefully, I'm using a default that has very, very narrow privileges, but it turns out that about 4% of the orgs running SageMaker have at least one notebook instance where it's running with admin privileges. In other words, it's running with the ability to access every EC2 instance in that account, which means if I manage to escape SageMaker in some way, because the default bucket name was used and I was able to get to it and inject something there, or however I do it, that gets me to everything. It's a very quick compromise of the entire account and not just one instance in it. That's pretty significant. Some of the other things. So IMDS is a way, and this is common really across the clouds, but this is the AWS version in particular. It's a metadata service where if I'm running on an EC2 instance, I can say, hey, tell me about this stuff. Tell me about where I am, what I'm doing, whatever else I need to know about the cloud that I'm in. Now, IMDS v1 was unauthenticated. Thus, it was very easy to do recon as an attacker if you were able to access it. IMDS v2, something I will invariably call IMDb at some point in the conversation, but IMDS v2 is authenticated. It's got a significantly higher bar to doing recon with it. And yet, 77% of the orgs using SageMaker are running IMDS v1 on those instances. So not only do 4% of them have admin privileges, 3/4 of them have the ability to do recon, figure out what cloud account they're in, what the rest of the sort of what's there, do a ton of recon and find their way around. So, interesting. By the way, this is significantly higher. 35% of all EC2 instances are not configured with IMDS v2. I don't know why this is significantly higher, except that people running SageMaker tend to click next, OK, rather than setting things up and figuring out what they need. Here's another one. I mentioned this earlier. 98% of all the SageMaker notebooks, or of the organizations using SageMaker, have not disabled root access from their notebook instances. So now we can see that, I don't know, people like to call them toxic combination of things, where I could have access to the default named S3 bucket on an instance running with admin privileges with IMDS v1 enabled, although that if I had admin privileges, IMDS v1's not going to, or IMDS v2 is not going to stop very much, and also running as root. So if I can break out, I can get the whole EC2 instance, I can discover everything, and I can access everything, which is a pretty significant set of problems. Another one here, Azure OpenAI can configure private endpoints, meaning that they're not publicly accessible. 27% of orgs haven't configured those private endpoints. Their Azure OpenAI accounts are publicly accessible. By the way, I'm going to plead, I was not an editor on this particular report. The graph here is backwards. It annoys me every time that I put this slide up. It should show the red should be the gray piece. But still, 1/4 of these are misconfigured out of the gate. A couple of other notes. I'm gonna go very quickly through the rest of this. Basically, nobody is encrypting their notebooks or training pipelines or models or accounts with self-managed keys. So the bar to decrypting them and getting access to them is lower than it probably ought to be if they have any significant data in them. So all of that, sorry, I've seen some chat, but when I'm presenting in Zoom, I can never see it.
You're good. I got you covered. I'm monitoring it.
Okay, awesome. So let me wrap this up, right? Like there's a bunch of challenges here. This is moving fast. Teams are doing it without security input. We don't have guardrails. We don't have policy defined. Um, it's nascent technology. I didn't mention it in here, but OWASP has a top 10 for machine learning and a top 10 for LLM Gen AI. They're both on V1. Um, they don't have a ton of they're still figuring out what goes in them. They're worth a read, but I suspect that they will change dramatically as we see actual attacks happen, as we see more sorts of problems show up. If you haven't reviewed them, I would strongly suggest it. I would also OWASP is a great organization, and it's all volunteer run. So there's a chance there, if you're interested in these areas, to participate in those working groups, help shape that. It's a good opportunity, I think, if you have a passion around it, or any of the other OWASP top tens. Regulatory compliance is obviously another problem. I don't think anybody's figured out how many of the regulatory frameworks we have apply differently or the same to Gen AI and machine learning. Uh, Resource misconfigurations we see as a significant problem. So what do we have to think about? I'm going to say there's a number zero here before I get into these six things. And number zero is 80+% of securing AI applications is the same as securing everything else. It's configuration, it's vulnerabilities, it's access. Like most of the things I called out as problems are problems if I'm running a Tomcat web server. They're problems anything that I'm running in the environment. Nobody look at Sean and his cat right now. It's incredibly distracting. But that I think reviewing all of the data, talking to everybody running AI applications and in general, like 80% of this, 90% of this is exactly the same as everything else. It's just that whole shadow AI thing where people are going around us, building these things, deploying these things, and we don't have guardrails. We don't have good policy there. So, having said that, beware of default settings. You've heard me hammer on this for the last 20 minutes. I think a lot of these things still have risky defaults. And so, it's important that you are training teams, preferably that you're moving towards using infrastructure as code and setting up appropriate controls around them. Whatever it is, you've got a way of ensuring that they're deployed with strong settings, and you can manage that and find that. Number two, be thinking about vulnerabilities and how you're finding them in here. I mean, the conclusion was they're not really interesting yet. That'll change in 2025, without a doubt. And you've still got to worry about all the vulnerabilities in non-AI packages that are part of your AI application, where there probably are some critical vulnerabilities. Isolate networks. Don't expose publicly what you don't need to expose publicly. Limit privileges. Don't run as root. Don't run as cloud services admin. Secure your data. Follow best practices. And there's a ton of best practice stuff coming out around this. OWASP, I think, is a good place to start, but I'm sure that people have lots of other suggestions. One other thing I'll mention, and I think I mentioned this before, but if you want hands-on, our research team built something called AI Goat, which is an AI application. Today, it illustrates 3 of the top 10 OWASP risks. They're building on that next year to try to add another 3, and eventually they'd like to cover all 10 in it. This is both a capture the flag exercise and a more general sort of example of how particular risks can be introduced into an AI application. So it's great to look at, and once again, it's something, if you want to contribute, it is an open source project. I know the team would love to have input and pull requests and work on it. And yes, you can in fact go to Wiz's website to find this if you like. You can also go to Orca Security, or even better, Orca Security-Research is the GitHub org. You can follow the GitHub org, start the project, get at it.
Yeah, I don't think it's on the Wiz website, but it is on the Cloud Security
Oh, I'm
Office.
sorry, Cloud Security Office Hours. I thought you guys had a Wiz website with all of this sort of stuff too.
We probably do. We have a lot of resources.
Yeah. Anyway, you don't need to know how Orca can help. You don't need to know about our customers. Any questions? And by the way, if you want the report, you can go there to get the whole thing. You've seen most of the interesting pieces already, but you want to share it with other people, feel free. I can tell you, you will have a salesperson not spam you, but reach out to you, since you did in fact solicit it. But then you can tell them that back to you again, politely if you would. But should you want it, there it is.
And I think, Neil, you brought up some interesting points, and I think that whether we have 10 people or the normal 80 people, right? But I think that part of me is a little bit remiss that I think you had some great talking points there. The number one, or one of the top things we talk about here, is just ways to get your hands dirty. And I think that if it on a normal week, I think this would probably cause a lot of conversation, right? Because I think I always like when you guys give entry points, like, okay, well, this is something that if you want to get your hands dirty and you want to kind of just play around with some things, I think this is a really good entry point for some folks. Maybe not beginner per se, but yeah, maybe that's something that maybe we spam out on Discord or something like that. But yeah, this is good stuff, man. Like, especially the OWASP link that you brought up. So good job. Kyle, what you got?
So, when you were talking about things being insecure by design, I was going to add that technically the whole internet is insecure by design. I mean, it was designed by the military and used by the academics, so a lot of things like anonymity and security and privacy weren't built into the internet by default. They had to be bolted on with like things like HTTPS and TLS and other stuff. So so many of us cybersecurity people are paying for that right now.
Yeah. And Kyle, I do want to differentiate. CISA talks about both secure by design and secure by default. This presentation is largely a secure by default set of problems. Like there's nothing in here that I can't go and configure properly, but the defaults in how I deploy it are typically set to make it easy and not secure. That's one of the two fights, right? But
Yeah.
It's one that in the cloud services I feel like we run into a lot, where next I get a set of I get a set of configurations that make it easy. My EC2 instance is as SSH exposed to the outside world by default. That makes it easy. I don't have to go figure out how to connect to it. I can just connect to it. That does not make it secure by default.
We used to get that. We used to get that all the time in the mid-range I-series, AS400 security software. You know, the password for, I can't remember, was it SQL? It was Scott or something, and it was always there. You'd go out and you'd search for it, and they were just horrific. It was default passwords all the way. So I don't know if you could. I was just thinking, if you can get into that core I-series stuff, which is different to the cloud stuff, can you kind of back into through that infrastructure through into the cloud bypass stuff?
Almost certainly.
Kind of entry point. From
What's an AS400? Never heard of that.
Yeah.
No, but Richard, all that stuff exists in the cloud and will forever, because people build stuff and leave ways in. I mean, they're finding. I mean, well, just last week, how long ago was it they found default passwords for service accounts on freaking firewalls, right? I mean, like, it's just, it's pretty much built in because humans built it.
And we used to find a lot of it was, okay, there was a process for when people left the organization, all right, Richard Murphy's left the organization, delete him from this. That request would go from human remains down into IT, and IT would say, right, great, we've got a name. He was in this department. What systems was he connected to? What do we need to remove him from? So they get maybe 30 names on day one of the first time they were trying this. They'd managed to get through maybe 1 or 2 by the end of the month. Then they get the next batch from human remains. There's another 30 names. You know, by the end of the year, it just got bigger and bigger. So by the end of the year, they'd done about 8, and they had a pile of 300 to remove. So you just think, forget it. It was just so difficult.
I created a security incident at Palo Alto about 2 years after I left. Because funny story, I was getting spam from them, or technically it was not spam, it turns out, but I thought it was spam. And I couldn't cancel it. The only way to remove myself was to sign into some website and then go change my preferences. I'm like, okay, let me figure this out. So I get signed into this website. I think I had to reset my password. It was a personal email address. And when I got signed into the website, at some point in time, somebody had added my personal email address to this system that managed all of these systems at Palo Alto. So I logged in and I could see every system that every SE had across like the entire organization. Sean's now trying to log in from one of those emails he's still getting.
Absolutely.
No, I still get them, and I tried to turn them off at one point, and I realized I had to log in like you were talking about. I'm like, not gonna do it. I just will send them straight to spam.
No, I was able to log in and I had access to everything. I was like, yeah.
So we had someone in the chat, Neil, ask about Try Hack Me, right? I know Udemy features them. Don't know too much in depth about them, but they said, how is that for cybersecurity, I guess, which is a broad question, but any thoughts there?
They're like 2 main sites for the cybersecurity learning. They're Try Hack Me and Hack the Box Academy. Hack the Box Academy has some really good certs, but they're not really seen as much by employers. But they teach you a lot.
Yeah, I can
There's
hop in as someone who's also relatively early in my career, I guess. And so the way I viewed Try Hack Me is you can use it to learn a lot of the fundamental stuff. It'll go into pretty neat detail on some of the topics. They do have a broad range of like different cybersecurity areas that you can go into the deep rabbit hole about, but you'll find that there's a ton of stuff there and you have to kind of pick what makes the most sense that you want to learn and kind of go there. But as with everything else, just doing courses online isn't really gonna get you much further than surface level knowledge. And so I'd recommend, like, if you're doing Try Hack Me or even Hack the Box, do the courses and then try to find practical ways of applying it. And so if it's like spinning up a box in a cloud provider and practicing the stuff that they talked about or whatever the case is, but I wouldn't stop at Try Hack Me, but it will get you a pretty good depth on some of the topics that they have on there.